The thing that you need to keep in mind when you are designing a plant is that each gold ore deposit is unique. So there must be a thorough understanding of the ore mineralogy in terms of the characteristics of the gold minerals, the gangue minerals, and the properties of the host rock as well. So a good place to start when you are selecting a processing route is to carry out a gold deportment study. And this is to establish the gold minerals that you have within your ore body, which will give you then an idea as to which processes are suitable. The gold deportment study also has the added benefit of establishing the acceptable tailings grade and identifying the speed. Okay, so on this slide, I've got a summary of the types of gold minerals that can be found in different modes of occurrence. So that can be as microscopic gold, as submicroscopic gold, and surface bound gold. I'm not really going to go into this long list, but during the ore mineralogy phase of your study, this is the types of minerals that you might encounter. Okay, so then this slide gives a breakdown of the microscopic gold minerals, showing the common gold minerals such as native gold, which is typically found as alluvial gold. There are also some gold alloys, such as those associated with PGM deposits, and gold amalgams from tectonic formations. Okay, so as previously stated, a gold deportment study is crucial for process selection. So the flow sheet on the left gives a summary of the gold deportment methodology, where each form of gold is analyzed for. By form of gold, I'm talking about microscopic gold, submicroscopic gold. They go into each of those different forms and identify the minerals associated with those. So the analysis includes your head gold analysis. A bulk modal analysis is also done to determine the composition of the ore. Next, it will include some sort of sizing analysis, where each size fraction is assayed to determine the distribution of coarse and fine-grained gold particles. Lastly, then, the recovery is estimated, and this is done by running gravity, flotation, and cyanidation test works. So the recovery that is then determined, if it is above 90%, then it is indicative of a high-grade free milling ore. But if the recovery is less than or equal to 80%, then the ore is more complex and requires more test work that simulates oxidative pretreatment processes in order to improve your plant recovery. Okay, so this slide just reiterates the full characterization test work, which needs to include your mineralogy tests, your ore textural tests, as well as metallurgical tests to get a full picture of the ore that is going to be treated within the plant. Also, to improve the performance of your operation, the data that you generate from your test work can be incorporated into a geometallurgical model. So this geometallurgical model rather, will consider the nature and characteristics of the ore, among other factors. And this is done to then predict your product volumes and qualities. Okay, the gold ore types. So gold ore is typically classified as free milling, complex, or refractory. So your free milling ores consist of oxides and your non-refractory sulfides. Then your complex and refractory ores contain varying compositions of auriferous base metals, and they also may be preg robbing as well. So on the right, I'm showing a diagram that basically ranks the different types of gold ores in the order of increase in refractoriness from top to bottom. So we can see that placers and the quartz vein ores are less refractory, they're more free milling. Then your most refractory ore is your carbonaceous sulfide ores. Okay, so for free milling ores, the typical processing methods applied are comminution, gravity concentration, flotation, leaching, and then some sort of concentration or purification stage, followed by recovery and finally the refining of your gold. Okay, then for complex and refractory ores, they require some form of oxidative pretreatment because they cannot be directly treated by cyanidation like free milling ores can. So the typical methods that are used are your thermal treatment, oxidative treatment, chemical treatment, and physical treatment. So thermal treatment is done by roasting, pyrolysis, and by smelting. Then your oxidative pretreatment, or oxidative treatments rather, is done by means of pressure oxidation in an autoclave. It can also be done by biological oxidation using bacterial cultures or by oxidation using nitric acid. Then your chemical treatment methods, these entail digestion using hot caustic soda, and even chlorination can also be used. Then your physical treatment methods consist of ultrafine grinding, and this is done to then liberate your gold particles that may be locked in with your refractory minerals. So if an ore is refractory, the level of refractoriness first needs to be established, and that can be done using the scale at the bottom of the slide. So we can see that if your recovery is between 90 and 100%, you've got a non-refractory ore. There's no need for oxidative pretreatment. If it is between 80 and 90, it is mildly refractory, or it may be regarded as complex, and it might require some form of pretreatment in order to improve your recovery. Then below that, you're dealing with a refractory ore. Now there you might need to consider then some form of oxidative pretreatment that will form part of your process flow. So then the selected treatment method that you choose out of these types that I've listed on the slide, this is then based on lab scale test work or a pilot plant test run that you may arrange. Okay, so on the slide on the right, I'm showing a diagram that shows the different types of flow sheet options that may be considered. So unfortunately, I don't think I've got enough time to run through all of them. There are many, and these depend on the type of mineralogy that you are dealing with. However, I do encourage you to contact myself or even send your queries to the VBCOM info desk for more information, and we will gladly assist in clarifying this, and maybe even assisting with a process flow sheet for your ore. Okay, so that is it for part 1. I think I can stop sharing, or maybe take it out of slideshow. Okay, so I'm ready for Q&A. Have I stopped sharing? I think I have. Yes. Are we going to jump straight into Q&A or?
Yes, thank you so much, Madam Napo. Mr. Gideon, is he there?
Yes, I was trying to unmute myself. Okay, can you hear me now?
Yes.
Yes, loud and clear. Okay, thanks for that, presenter, Ms. Napo. I think you've done well, but I think before we started, Dr. Sokoro said this is a high-level technical process when it comes to, especially when it comes to issues of metallurgical processing. I remember when we did some processing in those days in Benue State, it was very difficult getting through some of these processes, trying to get a metallurgist and all that. It's not been an easy thing. And because of the processes that are actually involved in this, most of the time people tend to boycott this process. But along the line, you find out that because they've actually not gone through the right selection method. In short, I know of about minimum of 4 plants that are not working right now because of wrong process. I can tell you 4. I know 4 right now that were not working because of this wrong selection. In short, most of the time, the major issues start from geology. The major issues start from geology. If you get your geology right, I think other things follow. But most of the time, you find out that the issue of geology is not actually given that priority. In short, some people import plants before they start exploration. I know one happening right now. The plant is already here in Nigeria, but exploration has not commenced. So you can understand what I mean. So I think that is okay. First of all, I would say that the essence of this is actually I will summarize it into 3 for achieving efficiency, profitability, and also, most importantly, achieve environmental stewardship. I think that's the essence of this. I have a question here, but I don't know. I have someone who sent just one question here. Maybe let's just read it out first. The first thing here, though it doesn't seem to relate, but I think you said, can you discuss the role of regulatory compliance in gold beneficiation and how mining companies for adherence to environmental and safety? I think this is for regulators. You get the question. He said, can you discuss that? But I think the role of regulatory compliance in gold beneficiation and how mining companies ensure adherence to environmental and safety standards. This actually is meant for the regulators of any particular country work based on their own structure. I think that it does as simple as that. Then first thing I have here before possibly I go to the platform is when you are making, let me just say, it's very straightforward because most of the time the issues that become on recovery, the issues that have been on recovery, 60%, 70%. I know it's not an easy thing to just put an absolute numbers in recovery when it comes to this. But is there any situation where we'll be talking about 95% recovery? Is everything being involved based on selection, what we just discussed? Is there anything like that?
Yes, typically, ideally, you would like your recovery to be around above 90%. So your ore mineralogy is not, your study into your ore mineralogy is not as comprehensive. You wouldn't have identified sort of your preg robbers, your refractory minerals within your ore mineralogy. And these are the ones that can have an impact on your recovery. So if, for example, you are mining in a certain location, and then you decide that you're going to move from this location to another, maybe for one reason or other, maybe there are logistical issues or maybe something else came into play, then the recovery is not going to be the same because you are now mining in a different area that was not studied. So it is basically recommended that before you move to another area that you first understand exactly what the mineralogy is of the new location that you are then mining in. So you can identify your minerals that can then affect your recovery. Maybe, for example, the area that you were first mining contained your oxide ores. So those are easy to then treat. However, if you move to a different area, maybe that has more sulfides or tellurides, for example, those are quite complex and can have then an impact on your recovery. You might want to then invest in some sort of pre-treatment stage, either including roasting or basically the list that I gave of thermal treatment methods, your chemical treatment methods. And to then establish how these can improve your recovery, you can run a lab scale test works, or you can have a pilot plant that you probably erect somewhere and then run your material through it for a particular amount of time, maybe a month or 3 if you would like more samples to be taken. And then you analyze that, okay, once I've sent my ore into a biox plant, for example, this then gives me an increase of 8% on my recovery. So I'm no longer at 80% recovery, I'm now at 88. So a full comprehensive gold deportment study is highly recommended. I think as a first attempt into designing a process flow sheet, a comprehensive deportment study is recommended.
Okay, thanks.
There.
Thanks for that. And another thing, before I go further, I looked at when you showed up your map. Sorry, I found out that I didn't see dots on Nigeria. Your presence is not here. I didn't see Nigeria on your map when you are showing your coverage. Why? What's responsible for that?
Are you talking about the first map where we are showing where VDCOM has done projects?
Yes, I didn't see Nigeria on your map. That's why. That's the question I'm asking. Why?
Have completed projects.
Okay.
So in Nigeria, we haven't yet had the opportunity to like fully get into the market and assist with our expertise.
Okay. Now, another thing interesting here is when you're talking about the issue of treatment in terms of thermal treatment and that has to do with complex ores. At what stage do you think, because I know there are processes, there are stages where you start bringing in some kind of treatment. At what stage is that actually done in terms of thermal treatment? At what stage can one bring in, in terms of if you have an ore that you tend to be a kind of a complex ore and all that, at what stage will you bring in thermal treatment? Kind of roasting and all that. At what stage of process?
Oh, okay. I think I'm going to get into it in the next part of the presentation, but essentially, if ever you have a complex ore, your pre-treatment stage will typically be before leaching. So you can possibly go for, you'll have your comminution stage where you then liberate your gold minerals, you crush it, you grind it to your optimal size. Then depending on whether you've got coarse or fine-grained material, you can then opt for a gravity concentration circuit where you can use something like a Falcon or an Elson or even shaking tables to get your coarse gold out. Then from there, you can either go to a flotation where you then remove your complex and refractory minerals from your stream. So after that, that is then when you have your pre-treatment stage where you can have your roasting or biox process. And then after that, you then leach, recover, refine. So typically, if you have a circuit with leaching, your pre-treatment comes before leaching.
Okay. I see. Okay, let's go to the platform now and see how many hands that are up here. Okay, I'm seeing Dr. Mrs. Salaus is raising a hand. Please, if you have any question, please you can immediately indicate so that we can actually call on you. Dr. Misalau, you can ask your question.
All right, thank you very much for this insightful presentation. Very, very interesting. From the presentation, there's one major thing the presenter mentioned. Every gold field has unique way of assessing and the beneficiation process is very important. I think it's contributed to one of the problems we have in Nigeria, though they have not yet covered Nigeria, but while you are covering Nigeria, please take note of these different types of geological mineralization and then the content of it. That's just what I want to bring out. That is a very unique point and is a really take home for every one of us that are present in this presentation. Because many license holders have come, examine their own field, explore as much as they could, and they find out that there is nothing. But it's not there was nothing. It was because they didn't use the right process of exploration and exploitation. Thank you very much. That's just my contribution.
Okay, I will just take one more question here from the chat here. He said that please he said that one that is coming from, okay. He said, can you provide insight into the integration of digitization and automation technology in gold beneficiation process? And what benefit do they offer in terms of efficiency and productivity? This is, okay.
Sorry, may you repeat the question? It's about
So can you provide insights into the integration of digitalization and automation technology in gold beneficiation process? That is, we are trying to see, is there any, if I should put it in a very straightforward way, I think asking of, what is the way forward of, what is the way forward in terms of artificial intelligence in beneficiating gold?
Oh, yes, yes. Another point.
What is the role of AI in gold beneficiation? That is, I think that is somewhere what she's asking here.
Okay. I think when we are talking about AI, that will then come into play when you're exploring the different types of technologies that you can apply then to your plant. I know that there are many different types of technology that are coming out. On my end, I'm not really 100% clued up on the different types of technologies, like the new modern ones. I know the standard procedures that are being used. But for example, in terms of AI and automation, there is a lot of innovation in terms of your remote controlling. So there are a lot of platforms that are coming into play that allow you to remotely control and to analyze your process. So it's not my area of expertise. That is something that I would have to get back to you on.
Okay.
Yes.
And there's something that has to do with your last slide. Mitchell is asking, can you explain one of the processes shown on the last slide?
Okay. Let me get my presentation and share it again. Zoom. Let me share that one. Yes. Okay, please let me know when you can see my screen.
Yes.
All right. Okay. Okay. So I'm just going to take any random route. So one option that is available Actually, wait, where's my laser? Let me get my laser. Okay, so we can start off with run-of-mine ore. And then from there, your option is to either grind and crush it, or you have the option of putting it on a heap leaching pad. Okay, on my end, it's taking long for the laser to move along with me. There seems to be a delay.
Yeah, but we're seeing it. We're seeing it.
Is it?
Crushing to
Okay.
grinding. Yep.
Okay, so you either have the option to crush or not to crush and send it straight to a dump or heap leaching facility, or you can crush. Okay, or you can crush and then send that to a grinding facility, or you can then, there are many options, send it to a heap or dump leaching facility, after which your pregnant solution will then go for ion exchange, can either go to a carbon in solution circuit for adsorption. From there, you can then go to an elution circuit. Then you have the option to then take your high-grade solution either to a cementation process, or either to electrowin your dissolved gold, and then take that through to your calcining, your smelting stages to then attain your bullion. Or if you don't take that option, coming back to grinding, or grinding rather, depending on whether you've got coarse or fine grained gold, you can opt then for a gravity concentration circuit to extract your coarse grained gold particles. Then your fines, so your coarse will go this way, where it can be captured using amalgamation. And then from there, you can then opt to take that straight to an amalgamation retort, and then attain and recover your gold that way. From your gravity circuit, you can then take your fines this route, and then either take it straight to the tailings, or you can then take it to for further treatment. Hold on, that is cons tails. Your fines go that way. Sorry about that. Take it to the grinding circuit, and then from there, take it through to your flotation stage. If you have an oxidative pre-treatment circuit or stage that you have approved, you can take it through there. From there, you can take it then straight to your agitation leaching or even pressure leaching, depending on what your lab scale test work results were. Then from there, you can take it straight through to thickening. It really depends. There's a lot of options, and it all depends on your ore mineralogy and whether you've got fine or coarse grained gold. So you can take it to a CIP. Really, the options are endless, honestly. So I think a comprehensive ore mineralogy study is what needs to be done to sort of inform which option is then taken.
Okay. Okay. I think that is this the complete flow sheet for different options based
Yes.
on the content or the ore grade and so on. Okay. I think that is fine. Maybe we can let's pause here for now. I think I will have other few questions, but we can start up the second part of it.
Let me just get,
We can maximize our time.
I just want to get rid of the laser. There we go. All right. So moving on to the next part. Okay. So now for part 2 of the presentation, where in this session, I'm going to be going through typical beneficiation processes. Okay, so if we can recall, and I think this was one of the questions that came up, is that the typical flow sheet for your free milling ores consists of comminution, gravity concentration, flotation, leaching, some form of purification or concentration stage, recovery, and then finally refining. So typically, if you have a complex ore, that pretreatment stage then comes before leaching. And that is then to liberate your gold minerals that may be locked up by refractory minerals, so that you can then, improve your recovery. Also, it is important to note that not all of these processes will be applicable to all circuits. So you might find that you've got a circuit that just goes for comminution, gravity concentration, and then that's it. You might find others that have all of these and others that maybe do not have oxidative pretreatment. It all depends on your ore mineralogy. Okay, so I'm going to go into the different types of methods that are then used for beneficiation. So I'm going to be starting off with comminution, which then consists of crushing and grinding. So crushing typically produces a coarse ore, and the equipment that is used for that includes jaw crushers, cone crushers, impact crushers, and gyratory crushers. Then grinding, that is applied for the liberation of your fine-grained gold particles. So you are then grinding finer than what your crushers can ultimately then produce. So mills are typically used for grinding, and that can be anything from your semi-autogenous mills, and ball mills, depending on what your textural analysis dictated. So the sizing and design of your crushers and mills, that is then dependent on your textural analysis, as we had discussed in the previous parts of the presentation, where you establish the work index of your ore. You also determine the specific energy that is required in order to efficiently break your ore to the optimum size. Okay, then gravity concentration is applied to recover gold and gold-associated heavy minerals. So the important considerations for your gravity concentration circuit include the gold grain size and its distribution within your stream, the degree of liberation and the particle shape. You need to also then consider your density differences of minerals within the stream and their hydrophobicity. So typical equipment that is used includes your shaking tables, drums can be used, spirals can be used, panning bowls can be used, as well as Falcon and Nelson concentrators. Okay, then flotation is a concentration stage that removes undesired material from your stream. So for example, if you have a stream where your main minerals are gold oxides, then flotation will remove your sulfides and your carbonaceous contaminants in the floats. It is then up to you when you are doing the design of the plant, whether you're going to then treat those floats or discard them. Then if your main minerals within your stream are gold sulfides or arsenides or tellurides, then flotation is then going to concentrate your stream in the floats, because your main mineral is maybe a telluride or arsenide. And then this will then leave your contaminants behind in the flotation tanks. So the important considerations to consider include the size of the gold grains, the composition of your stream, and the selection of your activators and depressants that are used in your flotation circuit. So the types of equipment that are generally used is your agitation tanks and your flotation columns. Then onto gold amalgamation, which is a simple method of recovering gold. And this was basically a method that was used during ancient times. So this method is better suited for gold recovery in small scale alluvial mining operations. However, it is also a popular method that is used by illegal miners. So the process is performed by contacting mercury with the gold-bearing ore to produce an amalgam. The amalgam is then distilled or it is heated to recover the gold. So this method is typically suited for alluvial gold deposits or material that has already been processed previously, but still has some concentration of free gold within it. Amalgamation, however, is less used in your big industrial operations, and this is because of the adverse environmental impacts that mercury has on the environment. So the typical equipment that is then used is your amalgamation cylinder. That is basically where mercury is then mixed with your ore, and then the amalgam retort is used to distill the mercury from your gold. Okay, then on to leaching, which involves the dissolution of gold from a solid particle into the solution phase. So this typically then occurs by chemical reaction where gold cyanide complexes are formed, and these are then readily dissolved into solution. So this whole reaction is governed by the Elsner equation. So the important considerations to include are the particle grind size, your reagent dosage, the presence of complex and refractory minerals within your mineralogy. Then the types of leaching that are typically used are agitated leaching, heap leaching, vat leaching, and intensive leaching. There is also in situ leaching, but I haven't included it for this presentation because that is commonly used for other commodities, not really for gold as such. Okay, agitated leaching. This takes place in tanks where the solids in a slurry are kept in suspension by air or mechanical agitation. So the image on the left shows an example of a Pachuca tank that is air agitated. Then the image on the right shows a mechanically agitated tank that uses rakes at the bottom of a flat-bottomed tank, and that is to keep your solids in suspension. Okay, heap and or dump leaching. This takes place at a designated pad, which is normally sloped, and this is where your ore is stockpiled into a heap. So a pre-conditioned leaching solution is typically sprayed at the top of the heap and allowed to percolate through the ore particles to dissolve gold. Then the pregnant solution then collects at the bottom of the heap and is recovered from there and sent for further processing downstream. Okay. So vat leaching. Vat leaching takes place in a vat, which is normally made using either wood or concrete or steel, where the ore is then immersed into the leaching solution. So this process was basically developed to minimize or avoid channeling and ensure that each surface of the ore is uniformly wetted, if that is a word. There is uniform wetting along all of the surfaces of the ore. And this is sometimes a challenge when it comes to heap leaching. So vat leaching is an older technology and it's not really commonly used in your big industries anymore. And this is due to the high operating and capital costs that were associated with erecting these types of vats. Then we have intensive leaching, and this takes place in a reactor at elevated temperatures and pressures, and this is then to ensure that your dissolution rate is increased. So this type of leaching is commonly used to extract gold from gravity concentrates, for example. So the diagram on the right shows a batch inline reactor, which was developed by Gecko. So essentially, the way it works is that your gold concentrate or whatever ore that you're going to be running through your reactor is added with your reagents. That would typically be lime, cyanide, and perhaps hydrogen peroxide to improve your DO levels, dissolved oxygen levels. These are then added to the reactor where leaching takes place. So the pregnant solution that is generated from the reactor is sent for further processing, maybe to an electrowinning circuit or to a precipitation circuit. And then the solids from there, which are now tailings, are sent to the discard facility. Okay, then concentration and purification is typically done through adsorption. Even thickening and filtration can also be used. So starting off with adsorption, this is achieved using activated carbon or ion exchange resins. And this is done to absorb the gold that is now dissolved in your solution onto the surface of your adsorbent. So this is typically done using a CIP or CIL circuit, or if resin is used, it will be an RIP and an RIL circuit. The dynamic is basically the same. It's just that your resin is typically then designed to selectively absorb the gold. Carbon will absorb a lot of base metals if they are part of your mineralogy as well. Then thickening separates your gold-rich solution from your solid tailings. So the solution is then either sent to a carbon in solution circuit or a resin in solution circuit, or you can then send it straight to a precipitation circuit. Okay, then we have desorption, which is the reverse of your adsorption process. So this is the process where gold is stripped from the surface of the adsorbent into a high-grade gold solution. So this is typically done using elution columns. Okay, so the recovery of gold is done by precipitation or electrowinning. Gold precipitation is done using zinc dust as a precipitating agent, and this is to convert your dissolved gold into a solid precipitate. Then electrowinning involves the deposition of your gold from the solution onto your cathode plates. So the important thing to consider is the type of mineral that you are going to be refining, security requirements around the handling of your high-grade concentrate material, the product quality and the purity of the gold that you are producing. So then depending on the product specifications, in the case of electrowinning, you can then opt to sell the cathodes as they are, or you can then further treat your material and generate a gold sludge that is then smelted to produce your bullion. Then similarly for your precipitation, you can then opt to sell your precipitate as a concentrate, or that concentrate can then be smelted to produce your bullion bars. Okay, to the refining of gold, this is done by electrorefining. where the bullion bar is placed as your anode in an electrolytic circuit. So your anode, which is now your bullion bar, is dissolved into an electrolyte solution, while at the same time, your dissolved gold is recovered selectively onto your cathode plate in a purer form. And this then leaves your impurities behind in the solution. And this is how your refineries generate gold that is at a purity of 99.99%. Okay, so finally, in conclusion, the gold beneficiation process selection is influenced by a number of factors, which we went through in part 1 of today's presentation. Similarly, it is very, very important for you to understand the type of gold ore that you're going to be treating. So a thorough ore mineralogy assessment needs to be done. A thorough technology test and pilot plant test work needs to be done. There needs to be proper test work that has been done, proper sampling that has been done for you to get the best and the most accurate measurement of your recovery. So lastly, I just wanted to add that at VBCOM, we do have a team of geologists, miners, and process engineers who are able to assist with any of your gold-related queries. So I might not typically be a specialist in something, but there might be somebody else in the team who then has a better grasp of that knowledge. So we are able to facilitate test work programs and conduct studies and designs for processing and mining operations as well. Okay, then I just want to end off here with a list of references that I had used in compiling this presentation, and I would recommend reading these books. Some of them are journals as well, just to get a nice basic understanding of the different beneficiation methods and your process selection process that you follow. Okay, then that is it on my end.
Okay. Well, thank you for that wonderful presentation. I appreciate your efforts. That was very well presented. Thank you. Do we have anybody here on question? Is there any hand? Please, if you have anything, you can actually raise your hand. But before that, I will. Okay. Therefore, I will say that the issue of gold in Africa actually this is the only mineral that you see that in all the locations I've visited in Africa, when it comes to gold mining, a lot of artisanal or illegal miners, or no matter the terms you might want to use, actually they're mining, because this is something that does not involve truck to horn. So anybody can do anything and just get away with it without even knowing whatever that is actually outcome of it. But the most importantly is the environment. Most of the places I've actually visited, the environment is an eyesore. You understand? And the most common one is the amalgamation. Most of the guys are actually using, which in every way is being preached that it's not actually good to one's health. And, and the leaching, when it comes to chemical, most people might not. Leaching is that most of them do not actually know how to apply this chemical. And sometimes it's not easily affordable, or actually they don't access it like the other ones, like just mercury. Is there any form of innovative or alternative beneficiation that you guys are looking at, or I would say that is in vogue? Because I've seen different methods coming up from different quarters that are being developed to improve gold recovery rates that will actually minimize environmental impact. Is there anything like that? you guys are working on, or something you can point to us that this is the innovative alternative beneficiation method that is actually tailored to see. The truth of the matter is that the only places you see artisanal workers, you see so-called illegal workers are in Africa. They are not in Europe. They are not in America. It's only Africa. And that tells you something is wrong somewhere. The only place you can see this is in Africa. Now, why are they not in other locations? Very glaring. So we must develop, let's not say we don't know, no matter what we do, some of these things are mining the creek. So whatever we are going to do, we must bring out a structure, we must bring out innovation that will make, even if the smaller groups of people are working on this, they might not have what it takes to go throughout the entire process and selections and all that. Now, this selection can actually be done by big mining companies. But 70 or 80% of guys that are involved in Africa mining gold are just individuals that do not even know how to write their names. 70, 80% I've seen. They can teach you every process of bringing the gold down to any depth you want, but they don't even understand what it takes to take care of their health or environment and all that. What they're after is that they want to put on the table for their children. So whatever we're doing in Africa, and we are not dealing with the reality of bringing innovation or alternative beneficiation method that some of these artisanals or cooperative societies could use, then we are not being truthful. Because what we are trying to do is, at the end of the day, we actually is like Africans folding their hands and their legs, waiting for Europeans to come and develop the gold mine. But we need to start somewhere. So my question summary, I'm trying to make these contributions and also put it as a question to you. Are there innovative or alternative beneficiation methods that are actually being developed, or that we are going to say, okay, we're going to be improving on this method that is actually tailored, basically, that actually deal with our needs in Africa?
Basically, to answer your question, the best method that is used in industry is cyanidation for extracting gold. It might not be the safest because it is a toxic chemical, but it is the best one that you can use to quickly extract the gold from your mineral. So unfortunately, yes, in Africa, we do have that issue of a lot of illegal miners operating using mercury, which is also a hazardous chemical, but there aren't any cheap alternatives for extracting gold. So amalgamation is appealing for a lot of individuals because of the cost associated with it. The other processing methods are more expensive. However, if you have a small mining operation, for example, something like heap leaching is quite cost effective. It is one of the most cost effective methods besides amalgamation that is used. But yeah, your concern is noted. There's a lot of journals and journalists that have done this sort of observation within Africa, that yes, we do have a lot of artisanal mining that is going on, and that is for people to sustain and support their families. But there needs to be better ways of regulating that kind of mining and making sure that it is safe both for the people themselves and for the environment. But unfortunately, we are not there, and there isn't really a quick fix that is cheap and cost effective enough to assist small mining operations. It does require some capital and investment into it.
Okay, thank you very much. A quick one. I don't know if this is within your purview, but someone, Dr. Comfort, okay, asking. I have an extraction facility and want to scale. How do we become bankable? Through adequate documentation. And the presenter guide us summarily
Sorry, can you repeat that? There is an existing operation that has an issue of?
Yes, you have extraction facility, and she's asking, how do we become bankable through adequate documentation? Is this something you can actually throw light on?
Sorry, are you saying fragmentation?
Okay, it's saying there is, it say I have an extraction facility.
Yes.
And I want to scale, kind of scaling up. Now, he said, how do we become bankable? He's just asking about what are the process of becoming bankable. You know, if you have any idea about this, can you guide?
Oh, scaling up the operation.
Yes.
Okay, that would require a review to find out if the equipment is able to then handle the increased capacity. So perhaps I'm assuming you have an operation that's maybe built to treat maybe 20,000 tons of ore a month. And now you want to then go to 50,000 tons a month. You would then have to do a review of the existing process equipment and figure out your limits. Where is your higher limit of your operation? If it is lower than what you would desire, then you would have to do a feasibility study, go into then designing of the equipment, making sure that it is then basically you size up your equipment. You design a bigger mill, or perhaps include an additional processing train to then accommodate the extra material. But even so, that still requires then a study to be done, especially if you're going to be moving into a different area where the mineralogy is unknown, possibly has some more complex materials that can then affect the efficiency of your operation. Not too sure if that answered you. I hope it did.
Okay, thank you. Another question here is coming from Anthony. Anthony said, he said, thank you for the presentation. Can we have more information about the key considerations when selecting a processing plant location? Key consideration in selecting a processing plant location, and how do this impact the overall efficiency and cost effectiveness of gold beneficiation?
Okay, so going back to part one, there was the geographical factor that you need to think about. So when you are doing your techno-economic assessment, that's now when you are weighing or doing an option analysis to see that, okay, if I have a plant that has flotation, is it going to be economically feasible? You then consider things like your geographical factors, because this will then affect your cost. So things that can impact that would be your climate. If you are in whether the amount of rainfall, for example, can affect your processing operations in terms of the movement of your material through the plant. So you might not achieve your capacity. You have to think about even the sunny weather, because this might affect the efficiency of some of the processes within your circuit that need to be temperature controlled. You need to think about the availability of water. So for example, if you've got a circuit that uses a lot of water, like a lot of the gold operations are hydrometallurgical processes, so you need water in a circuit like that. So you need to think about those types of factors when you are selecting where to place your plant, and make sure that you avail those types of materials and equipment for your plant to run optimally so that it doesn't break the bank, basically. I hope that answered you. Please do.
Okay.
So.
Thank you for that. Another one is coming from Nyore. He said a highly informative presentation, but can you please explain the potential risk associated with different extraction methods, and how are these risks managed to ensure safe and responsible mining practices?
different extraction methods? Are we talking about maybe
I
incorporating?
think, yeah, a different extraction method, but in summary, this will be what are the risks, potential risks that are associated with extraction methods that you've explained, and how can this be actually be managed?
Trying to think of a risk.
You know,
So
he didn't say, it's a big, he didn't say it's not particular with any method. It would have been easier. It's not particular with any method. It would have been easier because there are a lot of methods. So, and all these methods are, so it's like very wide kind of question. But you might just want to pick up risk. There are major risks. I know there are major risks that are actually associated with extraction of gold. And how can we mitigate this risk, you know, to ensure that we are mining professionally or responsibly?
I think when it comes to selecting your processing route, doing a risk assessment is quite critical. For example, if you have a processing plant that just does mineral processing where, for example, you just crush, screen, maybe run it through a spiral and then discard it, the risks are considerably lower than if you have involved chemicals within your process. Because if you have chemicals in your process, those are toxic and can have an influence on the environment and to the society that is living in your neighboring communities. So most operations have got crushers and mills, and those are quite noisy. So that also has a noise risk that is then associated to the employees working in the plant, to the surrounding community, to make sure that you don't noise pollute. So a lot of risks. There's noise, the toxicity of your chemicals, dust, the emissions that can be released during your thermal processes, your roasting, your smelting processes. So there's a lot of
There are a lot of, yeah. I would say the last visit, I was in a gold processing plant last week, and one of the things I saw there that it was difficult for me to even spend some minutes there was the dusty nature of the entire thing. The grinding, it was something else, and I found out that, like what you said, water is very, very important. Most of them we found themselves in a loop because they want to be closer to the primary sources of the gold ore. Sometimes they might not be actually having access to water. And during dry season, the natural water bodies are water courses dried up. So you see them struggling with trying to get water from far locations. And you are milling coming out from quartz and silica. You understand what silica is? The quartz has a high content of silica in them, and everywhere is just dust. I think when I saw that, it was one of an interesting, challenges that one actually need to look at. Water is very important.
No, definitely.
Very, very important when it comes to that. I don't know if there has been any method. When I was in Niger, in terms of, I found out that there was no water at all, no water in the desert. And there was a kind of plant I saw they were trying to put the boreholes and here and there and all that. But I was talking to them, is it possible to process the entire thing without water? Is it possible? Is there a method you can process using gravity and all that, process and get out your gold without water? Maybe a kind of electromagnetic kind of thing, because that is the only way. But no, I want you to look at it. Is that possible? Because most of the gold in the desert, there's no water around there. So they try to put in boreholes, 6 boreholes, and they struggle with it. Not everywhere you can get fractured formation that are aquiferous formation that actually use water for you to for such a process. So is there any process that one could actually use dry method and throw out and gold will come out?
Unfortunately, with gold, it's very difficult. It's very water
No,
intensive.
but if we are thinking of it, I think it should be possible. Gold is a metal, isn't it?
It is, but it depends
It's a
on
metal.
whether it is coarse or fine. So if it is coarse, then yes, it can sort of be visually seen and extracted. But if it's fine grained, you're going to struggle. You do need water for that one.
I'm
Yes.
thinking if there's a form of maybe a kind of a separation technique that will use magnetic method or something to bring out gold, no matter how fine it takes. Maybe using a kind of centrifugal force or something. Don't we have something like that? Not possible.
Gold is not magnetic. It's not magnetic. However, gravity concentrators can be used to remove your coarse-grained gold. But then you're going to leave behind your fine-grained golds and your recovery will be poor, depending on whether you've got more coarse or fine-grained materials.
Okay, that's good. Great presentation today and wonderful. I will maybe I need to Dr. Sokora, are you there? You have to take over from here. And okay. Thank you. I think you can round up.
Thank you, Mr. Gideon. Thank you. That was a good moderation. Before we conclude today's session, I would like to extend a heartfelt thank you to our esteemed Madam Napo, the technical presenter, for delivering such an informative and engaging presentation. Your expertise and insights have truly enriched our understanding of gold beneficiation, and we are grateful for the clarity and depth with which you shared your knowledge. And obviously, your dedication to excellence in your field is evident. And we deeply appreciate the effort you've put into making this webinar a success. Thank you, Napo. I would also like to express our gratitude to the partners of MMC here for their invaluable preparatory contributions. And it has really played a pivotal role in the success of today's event, talking about the initiative for the advancement of mining, earth science, and environmental protection, headed by Dr. Salawu and also co-managed by Mr. Gideon Owanfo. Thank you very much. And Rich Flood team also, thank you for your great contributions throughout the preparatory stage for this webinar. Lastly, for those of you who are interested in further engagements or seeking additional assistance, please feel free to contact Vibicom. You can contact Madam Napo or the Vibicom, email address. Okay, we're sharing another screen. I wanted to call
can it be shared on the screen?
Can it be shared on the screen? But I know it's info@vibicom.com.
You can share it, Madam. You can share that.
Yeah, share your screen. So those who are interested, please get in touch with them for more insight, valuable insights and consultations to move your project forward anywhere within Africa. Additionally, you can reach out to MMC office as well, the Africa Minerals and Miners Center office, for any further assistance or inquiries. You can also join the MMC network using the link in the chat box. MMC office, please drop the link at the chat box. Yeah, I can see the contact now. It's .co.za. Yeah, so you can take that and reach out to them. And also for any additional assistance, MMC's office is also available for you. You can reach out through info@mineralscenter.com, or you can reach out to us, beneficiation@mineralscenter.com. Just in case it's not about gold, maybe it's about lithium, cobalt, or any other commodity across the continent. You can reach out again to beneficiation at mineralscenter.com. Lastly, I encourage all of our participants to join the IAMISAP WhatsApp group. Mr. Gideon, please drop the group link to continue this discussion, share insights wherever you are in Africa. Please join that group and stay updated on future events and opportunities. You can also join the MMC WhatsApp group as well. And let us continue these conversations. On behalf of the participants and organizers, thank you for your valuable contribution to today's discussion. And I hope we begin to see good impact of today's presentations in our operations and in the scaling, like somebody used the word scaling. Let's scale, let's do things right, and let's expand our business tentacles. Thank you so much, and it is good afternoon, good morning, or good night from my side. Thank you.
Good night. Good afternoon. A beautiful one so far.
Yes, ma'am.
This is techno-economic recovery of gold. I can't forget the presentation.
Yeah, I picked that word as well. I wrote it down. I picked the word.
Yeah. So we have more to do.
Yes.
Yeah,
That's
thank
true.
you.
Yes, thank you. So, Madam Nepo, thank you, and my regards to the team members. Yeah.
Madam Nepo, thank you. We need to see you, more of you, in Nigeria. So wherever you are taking up your assignment in Nigeria, please don't forget to contact us.
Definitely, I will make a turn.
And Mali also. I'm scheduled to be in Mali. I want to also work with the Mali mining team, and I would be looking at inviting Napo as well.
Oh, Mali team, they are very consistent. Very consistent group.
Thank
I
you.
will definitely come through. Thank you so much.
You're welcome.
All right. Goodbye, our participants. I hope you had a very, very swell time today.
Yes.
Bye.
Bye-bye.
Yeah, bye.
Yeah.